Hello everyone. Today I am going to present on the topic needs of routing protocol. So this presentation is basically focused on routing protocols and the different types of routing protocols which are being used in real life, and through that we'll also highlight what are the needs of those different types of routing protocols. So let's get started. Let's start off with introducing what is routing protocol. So routing protocol is basically defined as a set of rules which is used by routers to communicate between the source and the destination. So what routing protocol does is that it stores routing information into a routing table. So that information can be moved from source to destination using that routing information whenever necessary. So each protocol has its own algorithm to choose the best path, which gives the best cost and best time results and other parameters like that. So we'll have a look at the different types of algorithms which are used in deciding the best path. So for evaluating the routing information and storing it in the routing table, there are some matrices which are used by different routing protocols. So the number of network layers devices along with the path, which basically means the hop count, then the bandwidth, delay, load, cost. These are the matrices which are used by different routing protocols, and these matrices then evaluate the routing information, and which is then stored in the routing table. So let's just highlight once what are the need of routing protocol. So routing protocol distributes routing information between routing devices. Okay, and this information is essential so that data packets can be transferred from one node to the other. So it may happen that there may be a topology change, or maybe there is a link fail. So if we do not store this routing information, then we'll not be able to properly transfer or move data from the source to the desired destination. So therefore this routing information is critical to ensure that packets reach the required destination. So there are different types of routing protocols. We will have a look at that. So for classifying or defining different types of routing protocols, there is static routing protocols, and then there is dynamic routing protocols. In real life scenarios, only dynamic routing protocols are used from my knowledge, and then dynamic routing protocols are then further divided into distance vector routing protocols and link state routing protocols. And if we have a look at the examples of distance vector routing protocols, then there is RIP, which is the routing information protocol, and IGRP, and then link state protocols have EIGRP and OSPF. So these are the most popular ones which I've included in this presentation. There are others, but I've decided to highlight these ones. Okay. So we'll have a look at the static routing protocol. So what static routing protocol is that the administrator manually assigns the path from source to the destination in the network. So it is good for small networks, so that there is security, and administrator himself or herself can decide the route which he finds the best, which he suits his needs the best. But when it comes to larger networks, then this becomes an issue, because it will become a tedious task to keep on updating and adding new networks and joining links between them and routes between them, finding the best path and so on. So it is not practical for larger networks. And in this scenario, if one link fails, then the entire network will go down. So this is why dynamic routing protocols have come into picture. And dynamic routing protocols, what they do is that they update the routing tables of the routers by using routing information from its neighbors. So what it does is it automatically discovers and maintain routes and calculate routes between the nodes. So because of that, we see the advantage that less work in maintaining the configuration when adding and deleting networks, because the routing information and the routes are automatically being updated and added. So the human effort is removed from it, and because of this automatic updation, the protocols automatically react to the topology change, and therefore it is more scalable. So it is suitable for larger networks, and it becomes easy to maintain and find routing information in them. Okay. So the types of routing protocols are distance vector routing protocols. So distance vector routing protocol is basically it calculates the cumulative distance between routers based on the hop count, basically based on the distance, number of routers nodes and it has to jump to reach that part. These are the two examples which I've highlighted earlier. And then there is link state routing protocol. So link state routing protocol is a bit sophisticated algorithm and it involves complex database and internet topology. So we'll discuss the examples of the link state routing protocol. So coming to the first distance vector routing protocol, which is the routing information protocol. So the routing information protocol allows routers to exchange their routing table at predefined intervals. So, and in this case, the predefined interval is of 30 seconds. So here are some characteristics of the routing information protocol which I have included, such as it uses the hop count metric and it supports 15 hop count limit, supports 6 equal counts, and the administrative distance. The administrative distance is 120. So administrative distance means the route that the protocol will choose. Like if there are multiple routes from a source to destination, then it will choose the best distance out of those, and that is where administrative distance is used. This is the diagram, the figure of configuring RIP. And then we see the interior gateway routing protocol. It was basically introduced to overcome the limitations of RIP, and the matrices that it uses is bandwidth, delay, reliability, and load. And in this case, the routing updates are broadcasted every 90 seconds. So in RIP, it was being broadcasted every 30 seconds, but now it is being broadcasted every 90 seconds. And it is used by routers to exchange routing information within an autonomous system. And what is an autonomous system? Let's say, for example, in Ranchi, we have the central node, and there are different networks, such as at BIT Mesra and then BIT Lalpur, then at St. Xavier's. These are different networks, and these networks are connected to that central node or central router. So this forms an autonomous system. Similarly, an autonomous system can be present in Patna, where there will be a central node, and BIT Patna and IIT Patna and IT Patna, all these networks are connected to that central node, and they form an autonomous system in their self. So these protocols which I've been talking about are basically interior routing protocols. They operate only inside the autonomous system, and the protocols which interact between two different autonomous systems or more autonomous systems, they are exterior routing protocols, which one I've included, and we'll have a look at that. So these are some characteristics of the IGRP and configuration of the IGRP protocol. So we'll move on. And then our first link state routing protocol is Enhanced Interior Gateway Routing Protocol, EIGRP. So this EIGRP is basically used by Cisco, and Cisco uses a different algorithm. It doesn't use Bellman-Ford or Dijkstra algorithm for calculating the path. It uses a diffusing update algorithm, which has been developed by people at Cisco and is being used. And the EIGRP is very, very much popular for large networks, and it uses bandwidth and delay as default activated matrices. So, and for updating its routing table and for its root directory, it uses neighbor table, topology table, and root table of the nodes, so that it can form its routing information table. Okay. This is the configuration of the EIGRP, which I've included for reference. And then there is the open shortest path first algorithm. So what happens that if there is a large network, then we can break down that large network into smaller areas, so that the router in one area knows less topology, like it doesn't have to handle a lot of nodes and a lot of a big network. So the router of that smaller area will not know about the information about other areas, and this basically maybe increases the security, and also it is easy to maintain a routing table when you have less number of nodes and less amount of information involved in your network. And so we can say that creating OSPF area result in smaller database, which reduces the memory consumption and processing. Okay, so OSPF maintains two-layer hierarchy consisting of backbone area and off backbone area. So like I said, one will be the backbone area and then other areas. And some characteristics of OSPF, which is AD value is 110 and supports hierarchical network, just like we saw a backbone network and off backbone network. and route propagation is done using multicasting. Basically, it can send information in groups. Okay, so we have completed our interior routing protocols. Now let's just have a look at one of the exterior routing protocols which I've included, which is the border gateway protocol. So the BGP is an exterior gateway protocol. Exterior gateway protocol, basically, I told you that interacts between different autonomous systems, and interior routing protocol is within the autonomous system. So in exterior routing protocols, the autonomous system is given an AS number, which is the autonomous system number, and using that number, the BGP protocol operates. The BGP routing table is comprised of destination IP address and associated AS path to reach the destination and a next hop router address. So these are the three parameters which are essential for implementing this protocol, and BGP is used by a lot of enterprises and internet service providers because there are different autonomous systems that are connected, and everyone is aware of that. So this is a diagram which I've taken from a Cisco case study, BGP case studies. So you can have a look and have a better understanding of what BGP is. And finally, this is a table that compares different algorithms which I've enumerated in the presentation, like the routing information protocol, OSPF, IGRPF, EIGRPF, and what type of protocol they are, distance vector or link state, and their administrative distance, what matrices they use for calculating the routing information, and the algorithm they use for calculating, and the cost of the path. So we see that RIP uses Bellman-Ford, OSPF, IGRP uses Dijkstra, and as I mentioned that EIGRP uses its own dual algorithm, which is diffusing update algorithm developed by Cisco, and also the kind of networks that these algorithms are suitable for has been mentioned in the column. Okay. Thank you for seeing my presentation. I hope I was able to convey some good information and enlighten you about the different routing protocols and how they are used and needed in today's scenario. Thank you.